at number 3, January 2024. Paper 2, CSEC Maths, at number 3. All right, so number 3 tells us that in triangle ABC, AC is 8 centimeters, BC is 5 centimeters. It says using a ruler and a compass, we have to construct triangle ABC, and they tell us that the line AB has been drawn right here. So they give us this line, and that's A and B, and we are basically to add the point C somewhere. AC is 8. So we know that this line has to be 8 centimeters. And BC is 5. So this line has to be 5 centimeters. This is just me sketching it out. All right. So we need a line from here that is 8 centimeters. And we also need a line from here that is 5 centimeters. And where those two lines meet, it's going to be C. So we have to construct it. All right. So let me just explain how I'm going to do it. I'm going to open my compass to 8 centimeters from here and make an arc 8 centimeters. That's an 8 centimeters arc from here. And then from this point, I'm going to open the compass to 5 centimeters and make an arc that is 5 centimeters from here. So it's going to be a 5 centimeter arc from here. And this is going to be an 8 centimeters arc from here. And then where these 2 points meet, where these 2 arcs meet, that's where I would complete my triangle. All right, so this is just me explaining what we're going to do. That's our placement points. But let's put it on the construction chart. The thing is, I don't know the length of this line, guys. I'm on the device. I don't know what the actual length of that line is. And so I'm just going to draw a line to represent the AB on my construction chart, and we'll proceed. All right, so let's do this. So construction chart is up here somewhere. There you go. I'm just going to draw a line for the AB to begin with, right? So let me just draw a line, a random line to begin with. Let's say that is our line AB. All right, as presented. Let's say this is a point A, and this is a point B. And we are trying to just do this construction. So I will bring in my ruler and also my compass, and I will open it to 8 centimeters. So position the compass at 0. As the question says, you have to use a compass and open it to 8 centimeters over here. That's what you would do. All right, and you would lock it, move the ruler. Let's use a different color for the construction lines. So I'm going to bring the point to A. I'm going to rotate up the compass. Let's make an arc somewhere around here. All right, so that red arc right now is 8 centimeters from the point A. All right, so that is that. So I need to now adjust it and do the 5 centimeters arc. So I'm going to bring back the ruler and I'm going to measure 5 centimeters on it. Let's measure 5 centimeters. I'm going to adjust the compass now with the ruler to 5 centimeters, point to point. So set this properly at the 0. And then adjust this to 5 centimeters. So let's say that this is 5 centimeters. You'll be more free to do it with your hands, right? I'm trying to use the device, so this thing is snapping. All right, so let's say that this is 5 centimeters. I'm gonna lock it, move the ruler. Let's just change the color to differentiate the arc. So I'm gonna put the point at this NB now. All right, rotate up across that first arc, and it doesn't quite meet it, right? So I have to go and adjust back the 8. So it goes that type. So that arc, that blue arc is 5 centimeters. I have to go back and make by the 8. So I can actually come back here and cut out the device, change it back to red, I can open it back out to meet this line and to meet it for me, and then lock it, and then continue the arc, close this one. But you could measure the 8 again. Right, so that is it. So with those two arc meets, the red arc is 8 centimeters from A, the blue arc is 5 centimeters from B. So all I need to do now is complete, use my ruler and draw straight lines from A to C. So this point here now is C where they meet. The intersection right here is C. And as I said, I just draw a straight line from A out to the intersection. That's my C. And from A to C, that's my AC. And from B out to the intersection. And if I were to write it, this line is 5 centimeters, while this one is 8 centimeters. All right, it is that. Question wants us to measure and state angle BAC. All right, so it's the angle at A right here. They want us to measure that angle. So I don't know what the correct angle is, but I'm going to measure with this device. Maybe I need to get the actual paper and do the construction, but I'm going to measure with this device, see what we get. And I'm going to see, I don't want to write it on the paper and put the wrong thing, but you know, we can understand. No, this thing has to be positioned carefully. Common mistake is a person to put the bottom of the protractor on the line. It is the eye of the protractor that must go on the line, the intersection of that baseline passing through 0 and at 90 degrees right here. That is where you measure from. And then the baseline that you're measuring from, which is the AB, must pass through 0. So you rotate and ensure that that baseline pass through 0 on the protractor. You can see the 0 here. And you position it so that it passes through 0. And you read the scale that is from 0. Remember, there are 2 scales. So there's a scale that's counting down from 180, and there's a scale that's counting up from 0. We need to read the inner scale this time, the one that is counting up. And in this diagram, to make the protractor a little larger for you, you would see that that angle is giving us 39 degrees. 39 degrees. All right, reading the angle this way from 0 up would be 39 degrees. 39 degrees up here from 0 up to that line would be 39 degrees. All right, everybody can see that. All right, so I'm going to put, I don't even want to put the 39 degrees in the but to be 39 degrees, but I'm not going to leave it because I don't know the length of this line. So I don't know the actual angle, because the actual angle will depend on how long that line is. I'm not going to put an answer here on the paper. All right, I'm just going to say measure. Measure. I'm going to put an arrow to say measure that angle right there. All right, that's the angle that I want. So I must leave it like that. Okay. So that is that. All right. So maybe what I need to do with this is use some colors as well. So I'm going to change the 8 centimeters to red. I change that to red. And I'm going to change it to red just to show. Change that to red. And I'm going to put a red dot here to see that we're measuring that line. That arc is from here, 8 centimeters. Also change this word, the number to red. I'm going to leave this one as blue. And then put a dot blue here to show that this arc would have been 5 centimeters from here. All right, let's leave that. But that is it. And then we'll measure to get that angle. All right, too much time on that question. All right, let's get back to this one. So this one is like a simple trigonometry. It says the diagram below shows the equilateral triangle. So what we know about an equilateral triangle is that the 3 sides are equal, and that is shown by these markings on the 3 sides. And this side is 13, means that this side is 13, this side is 13. So we can put that on, all right? It tells us the base is 13, right? So this is 13 centimeters as well. This side is also 13 centimeters. All right. In addition to that, the three angles are at 60 degrees. That's another feature or property of an equilateral triangle. So this angle is 60 degrees. All right. This one is 60 degrees. And the one up here is 60 degrees. All right. And this perpendicular bisector of the base will actually cut this half and half into 30 and 30. But anyway, those two being 60 isn't sufficient for what we want to do. It wants us to calculate the height h. So to calculate the height h, we can actually come and work in this triangle, for example, and use so-called tower. In that triangle, this should be at 90 degrees. This should be the opposite that we want, and that will be the hypotenuse. All right, so it can be done that way. It can be done more than one way. So I'm going to use that method first, and it's going to be sine of 60 equal the opposite over the hypotenuse. So the h will be the opposite, right? So we use sine. So the sine of 60 degrees would have been equal to the h over the 13 in that blue triangle. And then to get the h, I would multiply the 13 up here. And so 13 times the sine of 60 degrees would have been equal to the h. And so we could get the h that way. Let's just get the calculator over here. So it's 13 times the sine. Make sure the calculator is in degrees. Yes, it is. We can see the DEG of the top there. Sine of 60 degrees. That will be 11.26. I like to work with three significant figures, but this time I'm going to write 11.26 because I'm going to calculate it another way. Should I get the same answer? 11.26 centimeters. So doing it another way is to use Pythagoras' theorem now in this triangle. Now, what happens is that this line, it divides the base equally. And so, since the entire base is 13, this side right here is half of 13 is 6.5 centimeters. And so we could have used Pythagoras' theorem now in that same blue triangle. All right. And it would have been that, doing it another way, the 8 squared plus the 6.5 squared would have been equal to the 13 squared. 13 is the hypotenuse. It's Pythagoras' theorem. And so if we transpose and then square root, then the h would have been the square root of 13 squared minus 6.5 squared. And this will give you the exact same answer as before. Let's just show the one calculator. So it will be the square root of 13 squared minus 6.5 squared. See, same answer, 11.26 centimeters. So this is our method. We'll put the word or here. This is really or, one or the other, right? All right, so I've given 2 ways to do that one. You won't do both ways in the exam, guys. You only need to do it one way. I'm going to shift this one a bit. Shift it off the diagram a bit. All right. Next part. Oh, that is it. Okay. So we did the 2 ways to get the same answer. Okay, no problem. Next question is a transformation. All right. Let's see those diagrams. And it's a transformation. And it says, the diagram below shows 3 triangles, P, Q, and R. So this is P, this is Q, this is R. All right. It says triangle Q and R are the images of P after it undergoes a double transformation. So it underwent 2 transformations. So from P to Q apparently, and then PQR, and then from Q to R. All right. So let's assume that's what it is, a double transformation. All right. Question says, describe the transformation. So you have the single transformation, keyword is single. that maps triangle P onto triangle R. P to R. Let's look at them. P to R. P to R. Oh, it's P to R first. Okay. So if you look at P and R, they are oriented the exact same way. Dimensions are the same. There's no turning. Everything is the same on them except their position. So there's a change in position. And when there's only a change in position, that's a translation. And the translation will have two components, a horizontal and a vertical component. And we only need to see what happened to one point. So we can maybe use this point, for example. This point on the object corresponds to this point on the image. And we can count out the movement between those 2 points. Or better yet, let's use this one here and here are corresponding points. So count how many units to the right and how many units upwards to go from this to this. And that will be the components of the translation. And let's make sure I have the scale properly. Here will be 3, so every centimeter is 1. Here will be 1, so every centimeter vertical is also 1. So make sure you check that. And so counting out the units, it's 1. Let's go again. 1, 2 units to the right here. And then 1, 2, 3, 4 units upwards. 4 units upwards. The graph is there so we can count it off. So it's a translation 2, 4. It's a translation 2, 4. That's translation matrix. All right, but they want us to describe it. So to describe it, we give the name and the components. That's how many units to the right and how many units upwards it went. So it went to the right and up. Because it went to the right, this is positive. Because it went upwards, this is also positive. All right. So let's write that. It's a translation 2 units to the right, 4 units upwards, given by that matrix. So I'm going to write translation. It's the name of the transformation. Translation 2 units to the right equals to 2 units in the x direction, 2 units to the right, and 4 units upwards. I could say 4 units in the y direction, upwards. We can say given by, I think this will be sufficient if we give CSEC this. That will be sufficient for this description, but I'm going to add to it and say given by this translation matrix 2, 4. All right, matrix 2, 4. That is okay. Then we want a transformation that mapped R to Q. Okay, so we're going now from R to Q. All right, so if we look at these two now, we see that the orientation is reversed. And it is reflection line that reverses orientation. What do I mean by the orientation? So let's say that R at coordinate at vertices A, B, C this way. And that is anti-clockwise. The corresponding point to A will be here, A prime. Corresponding point to C will be here, C prime. And the corresponding point to B will be up here, B prime. And the orientation A to B to C on this one will be that way, opposite direction. And it is reflection in a line that reverses orientation. So look at it, ABC. This is ABC is going this way. And A prime, B prime, C prime is going that way. So the orientation is reversed. So when the orientation is reversed, we know we have a reflection. And why is that important? Because oftentimes students confuse reflection and rotation. So we know this is a reflection because orientation is reversed. And so the mirror line is exactly between them. There is a mirror line. The mirror line is halfway between B and B prime, for example. So the mirror line is right down here. Similarly, it's halfway between C and C prime, all right, which is again on this line right here. So we see that that line is our mirror line. Okay, so our mirror line is this vertical line that crosses the x-axis at 1. And so it is the line x equals 1. If you're describing a vertical line passing through one has an equation x equals 1. So when describing a reflection, you have to state the mirror line, or the equation of the mirror line at least. So this is a reflection in the line x equals 1. So we give the name, the reflection, and we state the equation of the mirror line. That's how we describe a reflection, by stating the mirror line. And that ends this question. This is number 3. And we'll do number 4 in the next recording. In the next recording, we'll start back at number 4. Okay, let's do this.